share screen. Okay. So what was the first question? Okay, are you still there?
Yes, sir.
Okay. What was the first question?
What is quasi-convex?
Then, given that
X1 is increasing.
no, y is
X1, X2 both are increasing. Yeah.
no, it was general that these are a function is quasi-concave, right?
Convex, strictly
Convex, convex.
quasi-convex.
It was that y is equal, yeah, it is strictly quasi-convex. And we had to sketch a typical level set.
Wait. Convex, right? Y
In
is
both
increasing
variables.
in both variables. Okay, let's suppose this is the question, right? So even if I have not asked you, mm, first you should start by defining the level set. Okay. So I'll first indicate the steps, then I'll go through this actual steps. After you have defined level step, derive the level set, only the slope. Okay. Then uh, you have to derive the map of the level set. Okay. After this, define quasi-convexity. Then, using this concept, find out the curvature of y. Okay. So these are the steps that you should follow. So what is the level set? Is given in high. Roughly, what we are doing is, if you are given a function, we set y equal to y bar. Okay. Then we find out the combinations of x1 and x2 that will give us y bar. Okay. So that means the level set is the combination of x1 and x2 that will yield same value of y. Say y bar. Okay, is this clear?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. So I'll just preserve this. So that I can send this to you later on. Okay. Yeah. Okay. Now we are given this function is increasing in both x1 and x2. So let us start with a arbitrary point A. Okay. So this is A. Then let us increase x1. So if we increase x1, we are moving to a point B. So we move to point B. This is, or rather, this will yield a higher value of y as y is increasing in x1, right? So we want y to be same. So therefore, again, given that y is increasing in x2, we should do what? How can we bring back y to the earlier level?
Decrease x2.
We should reduce x2. So that means we'll come to a point like C. Okay. This brings us to C. Therefore, the curve passing through A and C is the level set of the function. Okay. So this is the function. It can be a straight line, it can be convex, it can be concave. We don't know that. We only know that it is a negatively sloped line. Right? Secondly, therefore, the point passing through B will also be negatively sloped. But if this is y1, it will be y2. So we get a negatively sloped line, and if we draw a level set through B, it will also be negatively sloped, but the value of y will be higher. Okay, so that means points above AC is the better off set, right? So this is worse and this is better off. Okay, again, is it clear, everyone?
Yes, sir.
Achha. Now in the third step, we want to find out whether it is convex or concave. Achha. Now it was given that a function is quasi-convex. What does it imply? You have to give the definition. The definition is the verse of set is
Convex.
a convex set, right? Okay. Now it was given that a function was negatively sloped. Okay. So suppose the function is convex like this. This is the verse of set. So we take points on the verse of set and we connect it, right? So these are outside W, these points. Therefore, this function cannot be quasi-convex, right? So what is the other alternative? It is the function is concave. Sorry, I have not put it. In that case, if this is the verse of set, we take any 2 points and if we connect it, it's within the set. Here we can see that all points on W are connected by lines which are entirely within W. So it implies W is convex. Therefore, Y is quasi-convex, right? So the answer is it's negatively sloped and it is concave to origin. Okay. So is it clear?
Yes, sir. Thank you.
I'm just going through this again. First, you have to define what is a level set, which I've defined over here. Then derive the level set. Okay. So whether the level set is positively sloped or negatively sloped, that has to be derived. Which is the worst of set, that also has to be derived. Okay. And in the last step, using quasi-convexity, we have to find out the curvature. Okay. So generally we say that it is strict, or rather you can use the concept of strict. Either this function will be convex or it will be concave. You know what the verse of set is. Simply find out whether W is convex or concave. Okay. So your answer should basically identify two characteristics: the slope and the curvature. And remember that over here, you have to derive this carefully. Some of you have tried to go for, used the concept of, they've taken the second derivatives. See, firstly, you're supposed to use the concept of quasi-convexity. If you're taking second derivative, you're simply finding out whether that function is convex or concave. It will not help you to determine whether it is quasi-convex or quasi-concave. So you have not got any marks for that. Okay. Okay. So I was looking at the definition of derivatives and differentials. So I started by saying that uh, if we have a function, we can find out the tangent, which is this, and the slope of the tangent is equal to, sorry, the slope of the function at point t is equal to slope of the tangent, and it is given by dy dx. Okay. Then we introduce the concept of total differential, and we said that derivative is an approximation. It is given by fx2 minus fx1 by x2 minus x1 when del x tends to 0. Differential, on the other hand, is measures the exact change in y. So dy and dy dx and del y del x, the triangle, it will, the differential and derivative will in general not be same. We generally have a margin. So in that case, dy can be either an overestimate, as in this case, or an underestimate in this case. Here there's no difference. Now, why we still rely on dy dx is that as del x becomes smaller and smaller, the error term disappears. Epsilon tends to 0. So in the limiting case, dy and del y will be same. Okay. So we looked at the concept of differentiability, that the function must exist at that point. Uh, the limit should be there. That is, in other words, the function has to be continuous at a particular point. And the second condition is this: the limit fx plus del x should equal to fx. given that del x is very small. So that implies that if the function is discontinuous, it will not be differentiable. Okay. But if a function is continuous, that doesn't imply it will be automatically differentiable. We have to check whether this condition holds. So continuity plus this red line condition. If both are satisfied, then only the second order, then only the function will be differentiable. Okay. So these are cases when the function is continuous. Over here, it's continuous, but there's a kink. Here, the slopes are changing. Again, it's kinked. So in such cases, the functions are continuous, but because the second condition, this, is not satisfied, the functions will not be differentiable at these points. Here, here, here. Okay. Then we give the rules of differentiation and in particular L'Hopital's rule. Now we are coming to the interpretations. This is, I mean, you know the interpretations, I'm just emphasizing. Uh, what is the meaning of dy dx? So suppose we increase x by 1 unit. Okay. So that means increase means del x dx is positive. If dy also is positive, then dy dx will be positive. Okay, this. So the function will have a positive slope. It's going to be increased like this. Second is dy it can be equal to 0. In that case, it is horizontal to the x-axis. And if dy falls, that is dy is negative, if the function falls, dy is negative, then dy dx will be negative. The function is downward sloping or negatively sloping. In, now suppose dy dx is positive. In that case, again, we can have three possibilities. You can see in each of these cases, the function is rising. As x1 increases, y also rises. But the curvature is different. This is linear, this is convex, and this is concave. So this is given by the second derivative. So the first derivative gives the slope, the second derivative gives the curvature, convex. Okay. Now over here you can see that fx equal to x squared. This is the function, and you can see that it is it convex or concave?
Convex.
Convex.
It is convex. So the first, and it is upward rising, right? So it is positively sloped. So the first derivative will be positive. এখানে এখানে লাগবে দিয়ে দেবো একটু পরে আবার লাগবে ঠিক আছে নিয়ে নাও নিয়ে নে নিয়ে নে নিয়ে নে নিয়ে নাও নিয়ে নাও না 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 নিয়ে নাও ঠিক আছে আমি করে নেবো okay. So you can see that this is f prime x. This is always positive. Second derivative is constant. Okay. Second derivative is also positive. Right. So if the second derivative is positive, the function will be convex. See, this is also convex. Right. Okay. So that means if a function is differentiated twice, f double prime, and it is non-negative, then it is said to be convex. If it is strictly greater than 0, that is strictly positive, then the function is said to be strictly convex. So these are possible shapes of the convex functions. definition of concavity is just similar, the mirror image. So simple concavity is f double prime should be less than equal to 0, non-positive. And strict concavity implies that a second derivative should be strictly negative. It cannot be equal to 0. Okay. Okay. Now, let's try to solve this. You're given a function. What does it look like? So what is the first derivative of this?
So it will be x squared plus 6x minus 5.
Okay, who is it?
Shampriti.
Okay. Uh, and what is the second derivative?
The 2x plus 6.
2x plus 6. Okay. Now, put in x equal to 0 in the f prime function. What do you get? If you put in 0, you will get minus 5.
Yeah.
If you put in 1, what do you get?
Plus 2.
Plus 2. Minus কি করে হচ্ছে মাইনাস
Sir,
এক্স স্কোয়ার
0.
কত হচ্ছে
0, we
0
will get
হচ্ছে তো
0. Yeah.
so minus x square is 1 and minus 5 is 6, so 0. So if you put in 2, this is 4, 6 is 12. If you put in x equal to 2, what do you get?
3.
15, I guess.
2
So
করলে
won't it
তোমার
be 3
Plus 2, plus 3,
Yeah.
plus 3.
plus
Yeah, plus 3. Yeah.
f prime কত হচ্ছে সরি এটা 3 হচ্ছে না তাহলে এটা 9 হচ্ছে minus 9 3 6 are 18 minus 5 4 হচ্ছে না
Yes, sir.
sir? 4.
আচ্ছা তারপর if you take 5
So 0.
0 হচ্ছে
Yeah, 0.
তারপর 6 নাও
Minus 5.
Minus 5.
আচ্ছা এটা 7 নিয়ে শেষ করে দাও আচ্ছা ঠিক আছে এখানে এটাই ছেড়ে দাও আচ্ছা what are the second derivatives if you put 0 what do you get
6.
1
4.
okay 2
So 2.
আচ্ছা 3
0.
0.
2 3 4 and 5
-4.
-4.
Yeah. Okay. So if we do it till x equal to 8, we will get these values. Okay. Fx এর জন্য 8 f prime is this, and this is f double prime. Okay. Now remember what we said about minus, first derivative is minus. That means it is positive, it is negatively sloped. In this range, it is positively sloped. And in this range, it is again negatively sloped. Okay. So the function will be initially এটা হচ্ছে sorry, initially it's negatively sloped, then it is positively sloped, then again it's negatively sloped, right? And what is the curvature? So over here we can see, sorry, এটা হচ্ছে কত negative, this is positive, this is negative. আচ্ছা, what is the slope? You can see that initially the slope is the curvature, second derivative is positive. Okay, so second derivative is positive. So that means if it is like this, it is going to be concave.
Convex.
Wait a minute. And this part, it is going to be,
Concave.
so these were all strict convexity, right? So in the first part, we can see if it is convex, it is going to be like this. And this means the function will be like this. So if we join it, it's going to be like this, right? See, in the initial part, it is convex, then it is concave. Okay. Now work this out yourself. Now, you can see this function. So what you have to do, take the first derivative, put in values of x equal to 0, x equal to 1, ওই 6-7টা দিয়ে দাও, তারপরে f ডাবল প্রাইম বার করে সেখানেও x equal to 0 থেকে x equal to 6 অবধি দিয়ে দাও. But before that, just find out, tell me what is f prime and f
Minus
double prime.
2x square
It's
plus
2x
Wait a minute,
20x
wait a
plus
minute.
x
5.
plus 5.
F prime is
Minus 2x square plus 20x plus 5.
plus 20x and f double prime
Minus
Minus
4x plus
4x
4x
plus
plus
20.
20.
4x plus 20. If you take 2x square plus 2x plus 5. Five. Okay, if you write 20, this first derivative, can you simplify this? না এটাকে তো সিম্পলিফাই করতে পারবে না। Okay, so what you have to do is just plug in values of x and find out what is it.
So we will find the values of x till 6, right? I mean 6 or 7,
হ্যাঁ
like that.
6 অবধি করো।
So will it be a
Yes.
positive sloping curve because the f dash
Minus
x values
120.
are increasing?
X equals to 6, it is again 53. So it will first
Exactly, it's
increase, then
following.
decrease.
Increase and
Okay.
decrease.
Yes, yes, yes.
Okay. Suppose we take. Okay, it's increasing initially, right?
Yes, sir.
Yes.
Now, just look at the function type. Minus 2x square plus 20x. Okay. If we just take x common, we can write this as x within brackets 20 minus 2x, then plus 5. Okay. So initially, when x increases, it is still, even if you multiply by 2, it is still going to be less than 20. But after x equal to 10, what will happen?
So the slope will be negative.
The
At 11
slope
it is
will
minus
become
17.
negative. Yeah. So at initially it is going to be an upward rising curve, then it is going to be falling. So inverse V shape, right? Acha. Now if you take the second derivative, okay, before that, so it is going to be like this. Okay. Acha. Now the second derivative is,
Positive initially. Convex.
wait, wait, first I have to write it.
Minus 4x plus 20.
Minus
Oh, it's not that easy for me with a mouse. Yeah, very good. Okay. So initially it is going to be, see, 0, 1, 2, it is going to be positive. So second derivative positive means it's going to be convex. Acha. Then if x becomes, let us say, 10 minus 40, this part will be negative. So it is going to be concave.
Okay.
So it is going to be something like this. Uh, First part is convex, right? Yeah. So it is going to be like this, positively sloped. Then the slope becomes negative, like this. See, it is now concave. Now, logically, if this function is continuous, see, there must be a point. See, in this part, f double prime is positive. Okay. And here it is negative. So at some point, it should be equal to 0, right? This is called point of inflection. Sorry, I think I'm better right over here. So it is the point where f double prime is equal to 0. Okay, here also you can see that it is initially it is convex, then it becomes concave. So at some point, the second derivative has to become 0. So we will have a point of inflection somewhere over here. This is for the first function. The first function and second function is structurally similar. Okay, so this is something that it's not very easy. I haven't discussed this with you, but try to solve this. This is your homework. So you have a function y is a function of x, and the functional form is x equal to 1 by 3. Okay, and we are taking only the positive range. So using the production function, we have to find out the cost function and show that the cost function is convex and the production function is concave. Okay, so you have to convert, first work out with the production function. This is the function. Is it convex or concave? Then the second part is convert this into a cost function. Okay, what is a cost function? Cost as a function of output. Remember this. So that means cost is a function of y. Okay. So work it out yourself and try to show it to me. Now over here in Hoy's book, we have got several questions which I wanted to discuss. Find out the slope of, can you see Hoy's book, everyone?
Yes, sir.
Yes, sir.
Okay. I'll make it a bit larger. Okay. One is you're given certain production functions, and in each case, you have to find out the specific functions, whether it is positively sloped or negatively sloped. Okay. So curvature doesn't come in now. So in the first case, what is happening? Y equal to 10L.
Constant.
It is 10. Now, what is the implication of dy by dl? What does it give? Does it have a name?
Marginal product.
Exactly. dq by dl is marginal product of labor, and it is equal to 10. Okay. Now, if you look at the function as such, right, the function is positive. So that means Q will always be positive. If Q, if you consider L to be only positive amounts, Q will always be positive. Here, marginal product is positive and it is constant. Now, I'm not asking you about curvature. What does it imply about the production structure?
Sir, if we increase labor, then the production will increase.
That is given over here. Okay. Here we are getting something additional.
So if we increase the labor, the um,
Sir, each
additional
additional
output
labor
generated
will
will be
give
same.
10
Will
output.
It will be
10. It
same.
will remain the same.
Okay. If we increase labor by 1 unit, output will always increase by 10 units.
So TP will increase at a constant rate.
Yeah. Now, given that Q is equal to, let me see, 8, 1 by 3. Yeah. What is MPL?
8/3 L cup.
Okay. 8 by 3 is something like 2.67. Okay. And this will be,
So L to the power minus 2 by 3.
ঠিক আছে, তাহলে আমি যেটা, what I can write is simply I can divide it and remove the minus. Okay. So as labor is increasing, what happens to marginal product?
It will fall.
Will fall.
Okay, 3L4. 3L4. What is MPL?
12L.
12L.
12L to the power 3.
What happens now?
L
L will
increases,
increase.
MPL also.
And increase.
MPL is increasing. Okay. So the functions can be given like this. In the first case, what do we have? MPL is constant. Okay. In the second case, MPL is
Increasing.
decreasing. And in the third case, MPL is going up. Okay. Now, if the MPL goes up, we see that this is uh, law of increasing returns. If MPL is falling, we call it
Diminishing return.
decreasing returns. And this is law of constant returns. Okay. Now, if you want to combine this, the three laws, uh, I'm drawing the total product now. It is going to be like this. Okay. So over here, you can see that in the initial part, as labor increases, marginal product is going up. So this is the case of increasing returns. Okay. This part, as labor increases, total product is falling. Okay. Okay. Now, in fact, if you look at this carefully, let me, yeah, this part. It's not very evident from the diagram, but you can see that this part is convex and this part is concave. Okay. So initially what happens is as labor is increasing throughout the entire range, output is going to go up. Here, however, output is going to go up at an increasing rate. So this is the first phase. In the second part, you can see that output is increasing, but it is increasing at a decreasing rate. Okay. Over here, you can see as you increase output, sorry, as you increase labor, total, there will be a phase when total product will be, finally we have a portion when the total output is going to fall. So obviously, no producer is going to be no producer will produce beyond this level. If you increase labor, your output is going to go down. So in terms of output, you're not gaining anything, but you're losing because you have to pay the worker his or her wages. So this is the feasible zone of production till total product is constant. And as you can see that it is the point where it is constant is the maximum level. Okay. Okay. Now, if you look at this range, what will be the first derivative?
So positive.
Positive.
The first derivative is positive over here. So that means marginal product will be positive. Okay. If we label these zones 1, 2, 3, 4, we can see that in zone 1 and 2, the first derivative of marginal product will be positive. In zone 3, what is marginal product?
0.
0.
It is 0. Zone 4,
Decreasing.
Negative.
it is not decreasing, it's falling. Negative, sorry. Output is falling. Now, if we look at what is happening to marginal product, zone 1. Okay. So when you're increasing labor, your marginal product is positive. But does it mean that marginal product is increasing? See, what is the first derivative? You've got a function, you've got TP. If you take the first derivative, F prime, it is marginal product, right? if you take F double prime, this is dMp by dl. This is the slope of MP. It also gives the curvature of Tp out of the function, but F double prime is also simply thus dMp by dl, or the slope of the MP curve, whether it is increasing or rising, right? So in this zone, marginal product, the second derivative, F double prime, is positive. Okay. So what does it imply for marginal product?
It's
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 increasing.
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 It is positively sloped. Zone 2, F double prime. See, this part it was convex. Second part we said it was concave. So what do we have?
MP will be negatively
MP is
sloped.
decreasing.
Now MP will be negative. Okay. So MP is falling. This is the portion of decreasing returns. And this is increasing returns. Okay. Or you can say that this is the zone where you have diminishing marginal productivity.
Sir, I have a question.
Just 1 minute, please. Yes.
Sir, why have you written MP is less than 0? Matlab, sir, DDX of MP is less than 0, right? MP is still positive. It's negatively sloping, but it's still greater than 0, right?
Yeah, sorry. It should be M prime, MP prime. Thank you. Okay, is it correct now? No, the zones are, yeah. Okay. So MP rises over here, MP falls over here. So if you want to draw the uh, curve, the marginal product curve, what will happen over here? MP is initially rising, right? After this, MP is going to fall and it is going to be equal to 0 over here. This is the MP curve. So initially you can see in zone 1, MP rises. So it is like this. In zone 2, from zone 2 onwards, MP is falling, right? In zone 3 also, you can see, you can check that here also, zone 3 and 4, what do we have? F double prime. It is still convex, right? So MP will still continue to fall. Okay, so after rising, it falls. The only difference is in this part, it is positive. So it is false, but it is the value of MP is still positive. In zone 3, Z3, MP is becomes 0, and in zone 4, MP becomes negative. Okay. So if we draw the total product curve and the marginal product curve, it will be like this. And how can we draw the average product curve?
Similar to MP, but it will not be negative.
Okay, why cannot be negative?
This total
So because
product can never
TPYL is
be.
never negative.
Yes.
Agree.
See, we do not, uh, no sensible producer will produce over here. But suppose we go on increasing labor, just for the heck of it. What will happen in that case?
Total product will decrease.
So if I go on, yeah. So if I draw this, now total product has become negative, right? But as I've told you that we will not be, no sensible producer will produce at this point. Okay. So the average product will continue, will initially rise. It will be inverse U-shaped. Okay. Now, will it go like this or will it be like this?
Initially, it will be below MP, sorry, and then it will cut MP, be equal to MP, and then it will start falling, but it will remain positive.
Why will it be below MP? Can you prove it? What you're saying is it will be like this. Your answer is right, but can you prove this?
MP falls faster than AP
Why?
because MP is calculated on the basis of just one unit of input, but AP isn't.
You remember this?
Yes, sir. It will be AP plus L DAP over DL.
You remember this derivation?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
Okay. So we had shown that when MP is rising, sorry, what was the relation? MP is equal to,
DAP by DL into L plus AP.
AP plus L into DAP DL.
slowly, it is AP,
AP
AP plus
huh,
L into
L.
DAP DL.
Yes, sir.
right? Okay. So if MP is positive, or rather if DAP is positive, then we have to add this. MP will be higher. But if MP, AP is falling minus, then AP will be greater than MP. So we are simply showing this relation. Here AP is rising, so MP is basically AP plus something. Here it is AP minus something. That is why MP is below AP. Okay, so be very careful of this diagram. You can see that it is initially total product is initially convex, then it becomes concave. Uh, the MP curve is like this. Initially, it is going to be positive and then it is going to be negative. It touches zero at the TP max. It is negative afterwards. And the AP will be like this. Positively sloped, then negative, and MP will cut AP at the maximum. Now this point, where the MP is 0, you will see that over here, the curvature shifts from convex to concavity. So this is the point of inflection.
So could you repeat the last?
Okay. This is the point of inflection, where the total product curve stops being convex and becomes concave, just at a switching point. See, initially, what is the second derivative? It is positive. Now the second derivative is negative, right? So if the function is continuous, then at some point, see f prime double prime is positive over here. Then it is negative over here. So at some point where it is switching over, f double prime has to be 0, right? So you're basically switching over from convex to a concave zone. Okay. Okay, so let's end the class today. Any more questions?